for anyone looking at rocks, they find it very difficult to imagine anything other than the landscape they're seeing. So if we look out of the window, we see these ranges sticking up out of a desert plain. As you said, we are maybe 200 kilometers from the nearest ocean and more like 600 kilometers, 400 miles from open ocean. What would have happened to have taken the ocean that far away from the rocks that we say were formed on the seafloor? And the answer is very complex, because when we look at even quite young rocks, we often don't realize that the sea level changes dramatically through time. As little as 10,000 years ago, you could walk between Australia and Tasmania, which is an island to the south of Australia. And the Aboriginal people did that. And that was because most of the waters of a large proportion of the water in the ocean was stored on Antarctica and Greenland and North America and Northern Europe as ice. That was the last ice age. When that ice melted, sea levels rose and cut off islands from mainland and stranded people in places where they could not walk back to see their neighbours. So that's just in a few thousands of years. In a few millions of years, you have another effect. Not only is the ocean going up and down depending on the climate, but the continents are moving from one place to another. So this process of moving the continents, or the crust of the Earth, is really what explains a lot of geology. And we have evidence that's happening. For the people who live in California, they have evidence almost every day of that happening, because the coastal part of California is on its way up to Alaska. It's slipping past the eastern part of California, and that's along the San Andreas Fault. So you can measure that very easily. You can measure it's measurements we can make today. And from the moon we can measure continents like Australia moving away from Antarctica. Okay, so a lot of evidence that this movement is happening. And if we go back many millions of years, we move whole continents across the globe from one hemisphere to the other. And every now and then they get an ocean basin, something like the Mediterranean, and they squeeze one side of the Mediterranean against the other and force up the seafloor deposits into mountains. So in many parts of the world, you can go and look at rocks that are in mountains, and those rocks have shells that you can still see on the seashore today. How did those shells get up into those layers of rock way up on top of a mountain? They got there because two continents squeezed together and forced the rocks up into the air, well away from the oceans. That's the great geological cycle, and it's one of the most fascinating things about geological sciences, is just going back through time and looking at all of those processes.